Okay, so today we are going to talk about solving for velocity. And yesterday, or not yesterday, but before this the video before this, Mr. Peterson talked to you about graphing practice. So any notes you wrote down for that, make sure that you leave them on the previous page. And this is the next page. I'm on 9. I put the date as 10/7 or 10/8, just depending on what day you decide to do it. Doesn't matter to me. So in this case, when we start talking about velocity, we are going to switch gears just a little bit. Most velocity problems, you're going to be given one distance, and you're going to be already given the entire distance. It'll just be a one direction thing. So they're not going to say necessarily the displacement most of the time. They'll use the word distance, but they'll still ask you to solve for velocity. So please don't let that get confusing. In physics, we do know that they are different and they're used differently when we're talking about how to solve for each one. But do note that a lot of times in story problems, they'll just say 15 kilometers. And then you're just supposed to know that's the distance or displacement that they're asking you to use. So a lot of times, even when you get on Google and you just ask, what is the equation for velocity? Most of them will say displacement, but you'll see a lot of them also say distance divided by time instead of displacement. So try not to get too confused on that. We'll kind of use them interchangeably in this case. So every equation that we do in here for velocity, force, kinetic energy, potential energy, they're going to have these things called variables. The variables are the letter that represents the actual concept we're trying to find. So in this case, the variables for velocity or distance and displacement or time, they're going to have a letter that represents them. So the variable for velocity is going to be v. And the variable for distance or displacement we use is d. So I'm going to say displacement because that's what we know velocity is, but I'm also going to put a slash distance because you're going to see them both used interchangeably in story problems. So unless they specifically say they went down and they went back, find the displacement or the distance, assume whatever distance or displacement they give you is what we're going to use for velocity. And t, which is time. So every variable also is going to have units that go along with it. So velocity, we've already talked about it. The standard unit, it has to be a distance and a time. So the standard unit we use is a meters per second because it's a distance divided by a time. So therefore, if the distance is our displacement is meters, then we're going to have meters there, and time is going to be in seconds. So if we divide a meters per second, we get a meters per second. And so that might give you a hint. Looking at that, I just told you we divide in meters by second. That might give you a hint to say, oh, velocity, we've done it before, but it reminds you that it's a distance or displacement divided by time. So that is going to be our equation. So we're going to use the equation quite often throughout this rest of this unit. And we're going to not only have to solve for v, which is velocity, sometimes we might have to solve for the distance or displacement, and sometimes we might have to solve for time. So we probably remember if you're in algebra or even pre-algebra, a lot of times we have to rearrange the equation. Some people rearrange the equation first. Some people plug in all the numbers, put the x wherever they're looking for it. So maybe they're looking for time, they'll put the x down here, or maybe they're looking for distance, or maybe they're looking for velocity. Whatever one they're looking for, then they can solve by rearranging. I'm going to give everyone a little trick though. So there's this thing we call the circle, because it's a circle. You take the circle and divide it in half this way, and then you divide the bottom in half again. So you have a top and then 2 on the bottom. So in this equation, distance actually goes on top, distance or displacement. Velocity and time go in the 2 bottom spots. So how do we use the circle? So if I was going to rearrange the equation without using the circle, and let's say I wanted to look for distance, okay? I might have to remember that distance over time. Okay, so if I want to solve for d, I need to get it by itself on this side of the equation. So in order to get rid of t, because I want d by itself, I have to multiply by t over 1. It's going to cross out t because they cancel, and that gives me what I do to one side, I have to do the other, multiply by t over 1. Now I have, technically the ones don't really matter, right? Because they're that fraction over 1. Here's my equation that's left. I have a d equals v times t, okay? So now I am going to erase kind of what I wrote just so I don't get too much confusion. That's how I would rearrange it if I was doing it before. Some of you might want to just plug the numbers in there. You might actually plug in an x for distance, plug in a number for time and velocity, multiply by the time, figure it out. If you're in an algebra class or geometry and you know how to do this, keep it up. If you don't know how to do it, here's how the circle works. Okay, so if I'm solving for v, velocity, this is the main equation. Whatever you're solving for, you cover it up. So I'm looking for v in this case, I cover up v. What's left? D and t. And how are they arranged? D is on top of t, just like I see here. D is on top of t, therefore it's distance divided by time. So velocity equals distance divided by time. What if I'm looking for distance? Cover it up. Distance equals, because whatever one I'm covering up, that's distance equals, what's left? A velocity and a time. How are they arranged? Next to each other. So in this case, you'd have something like this. A distance equals velocity multiplied by time. Okay? What if I'm looking for time? T. Cover it up. D divided by V. D is on top of V, so therefore you're going to end up with T equals D divided by V. So there's our three equations. Now, in most cases in the notes, I'm not going to give you all the equations rearranged. You're going to have to know how to either use the circle or do the algebra to rearrange it yourself. So what I did here, though, was I gave you how to solve for distance, how to solve for time, how to solve for velocity. Okay, so let's try some example problems. So the first problem is going to be, what is the velocity of a car that drives 65 miles in 1.5 hours? Okay, so here's my technique. I like to do this method for all of my problems. I'm going to do it every time as I'm showing and teaching you. You can eliminate certain parts of it as time goes on and you get more comfortable, but knowing the method is super helpful for when we get to harder equations later on in physics. So my first method is read the problem. What is the velocity of a car that drives 65 miles in 1.5 hours? Then I underline everything they give me. So any numbers with units they give me 65 miles in 1.5 hours. So I'm given a distance and a time. And then I circle what they're asking me to find. What is the velocity? So now I know what I'm looking for and what I have. Now, I then take all three of the variables and I write them down. There's a V, a D, and a T. I need all three. Doesn't matter which order, because I'm going to put an X in whichever one that I'm going to find. So if I'm looking for velocity, that's what I circled. That's going to be my X. Now I need a unit to go with that because I need to know what I'm finding it in. And in this case, I have a distance in miles and a time in hours. Now, if I remember up here, whatever my distance and time is, that's going to be my unit divided by each other in velocity. So I'm going to use a mile per hour. Now my distance, or displacement in this case, is going to be 65 miles, and my time is 1.5 hours. So we're using our base equation, the V equals D time divided by T. So I'm going to plug in these numbers right into this equation. So X miles per hour equals 65 miles divided by 1.5 hours. Now I have two units, one on top, one on bottom. They're not the same unit, therefore neither one of them cancel. So now all I need to do is divide. So I'm going to take 65 into my calculator, divide it by 1.5, and I'm going to get 43.3 miles per hour. Pretty simple. Okay. Number 2 is going to look for something different. So we just found velocity. Let's find something else. So I am traveling 38 meters per second for 20,156 seconds. How far did I go? I break this so much. How far did I go? So again, I'm going to use the same technique. Underline everything I'm given. I'm traveling at 38 meters per second. That's the velocity. For a time of 20,156 seconds. That's a time. How far tells me I'm looking for a distance or displacement. Did I go? So again, I still need the same variables, v dt. I told you it doesn't matter which order because we'll just rearrange it when we're plugging it into the equation. So this time I'm given a v, a velocity, 38 meters per second. I am not given a distance. I'm asked for the distance, how far. So it's going to be x, and I just have to look at my velocity. It's in meters per second, so therefore my distance and displacement have to be in meters. Oops, I didn't need to make that up there. I can set it right next to it. There we go. And my time is given to me at 20,001. Holy moly. I need new lead. 156 seconds. It's a big number. So now I have to use my rearranged equation. So I'm just going to really quickly remind you of the circle so you can practice using it without me showing you the equations exactly. So if I'm looking for D, I cover up D and I have V next to T. So they're going to be next to each other, which means they're multiplied. So it's going to be D equals V next to T. So V times T. So I'm going to plug in all of this into this equation. D is x meters. My velocity is 38 meters per second. And I'm going to multiply that by 20,156 seconds. So notice I just put parentheses around it to remember to multiply. So I am now going to do the math. So I don't know what that number is. I'm going to plug it into my calculator. 38 times 20,156. And that's going to give me equals, I'm going to just pop it down here, 765,928. Now, we know it's a meter, but I'm going to show you how we got to that. So we have a meters per second multiplied by a second. So I'm just going to show you down here. If I have a meters per second times a second, remember anything by itself is always over 1, right? So I have a meters per second multiplied by a second. If it's over 1, that puts a second on top here. We also have a second on the bottom here. What do we know about cross canceling is if we have something the same on the top and the bottom, we can get rid of them. So by getting rid of them, that equals a meter over 1. Well, anything over 1, we don't really need the 1 anymore. It leaves it by itself. That gives us the meters. So you can check your units as well and know that we are on the right track because we got rid of the seconds and left us with meters by itself. And that's what we needed, was the distance or displacement. Okay, last one, we're going to try to solve for time. So how much time did it take my dog to run 250 meters at 4.5 meters per second. Okay, so in this case, same method. How much time, that's what it's looking for. And I'm given 250 meters, so I'm going to underline that, and 4.5 meters per second. So again, I'm going to write my variables down, v, d, t. I'm given a velocity this time of 4.5 meters per second. I am given a displacement or distance of 250 meters. And I'm looking for time. So this time will be the x. And since we have a meters per second in our velocity, we know we're searching for time in seconds. So always look. They all have to match up, meters and seconds, or kilometers and hours, or centimeters and years. All of it has to match up. So make sure that those always match. Okay, so now I'm going to plug it into my equation, but I got to figure out what is my equation again. If I'm looking for t, I cover it up, and I get d on top of v, or d divided by t, or I'm sorry, v. So t equals d divided by v. That's my equation. So I'm just going to plug these numbers in. X seconds equal, so that's my t. My d is 250 meters, and I'm going to divide that by my velocity of 4.5 meters per second. Now notice I'm kind of stacking them just because it helps with the algebra part of it. I'm going to show you how we get to our equation again, our units. So just for the sake of numbers, 250 divided by 4.5 equals 55.6. So we're rounding up to 55.6. Now, we already know we were looking for a time in seconds. So we know we're going to get that. So you can just put that. But I need you to know, how did it work? So in